Alrighty. Good afternoon, everybody. Welcome to another Aquarium Online Academy. I'm going to go ahead and step on screen. Good to see everybody. My name is Tina. I am one of the education specialists here at the Aquarium of the Pacific. You are joining us for an afternoon session of Aquarium Online Academy. Today we're going to be talking all about coral reefs, which is going to be very cool. It's one of my favorite topics. Now, during our program today, if you are watching us live on October 23rd, 2025 at 2 o'clock Pacific Standard Time, we would love to hear from you. We would love for you to interact with us during our program today, and you can do so by texting the number below. You can text us in any kinds of questions, observations. If you just want to say hi, you're more than welcome to text us at 562-286-1838. Again, we want this to be as interactive as possible, so if you do have those observations, we would love to... Oh! I just knocked my microphone off. We would love to hear from you. Now, if you're not watching us live, that is absolutely okay, but we would still love to hear from you. If you are able to, feel free to still email us your questions and observations at live@lbaop.org, the email that's right below the phone number. One of my coworkers does monitor that email, so we will still be able to interact with your questions and comments and observations, even if you're not watching us live right at this very second. Now, my friends, what I would love for us to do before we get started, we are going to warm up our scientist brains. And we do that by making some observations. An observation is something we do using our eyeballs. We use our sense of sight and we look around our environment, take notes in our heads about what it is that we are seeing. I would love for all of my scientists watching to make some observations of this beautiful video that you see behind me. This is actually one of the habitats that we have here at the aquarium. This is where we have some beautiful living coral, as well as some friends that love to live within the coral reef. So I'm going to step off screen. I want you to make some observations. Again, if you would like to share those observations, you can text us at 562-286-1838. Now, an observation can be anything from you're noticing a color, you're noticing maybe a specific shape. Maybe you want to tell me what you see or what you're noticing the fish do. Are they moving together, separately? Is there a certain group, or are there certain groups of fish that are staying more closer to a certain area? Maybe we see other animals in this habitat that aren't fish. Maybe we're seeing some other animal friends in here. I'll also take predictions as well. Maybe you want to tell me you think the water's cold or you think the water's warm. Maybe you can predict what these animals might eat. That would be quite interesting. Now, again, we are talking about corals today as well. So if you would like to drop in any kind of coral information you might have, or start thinking of some questions that you might have about coral, so that when we really get started, I'll be able to help answer those for you as well as a part of our program. Oh, Overland Avenue Elementary, our second grade class. Oh my goodness, that is awesome. Thank you so much for watching. Hello to all of you wonderful students. Students, I would love for you to work with your adults in the room, or maybe work together, collaborate as scientists. Ask each other what you're seeing. Maybe some of you are seeing the same things. And for my lovely educator in the room, feel free to text us in. How many kiddos do you have watching us today? We're always trying to improve our programs. We're always trying to see how many folks are watching in. So, if you would like, feel free to text us back in at that number to tell us how many kiddos you got. How many little scientists do we have watching us today? Oh, we got some observations. Excellent. What do we got? Nora notices a lot of orange fish. Nora, excellent observation. I would absolutely agree with you. And Nathaniel, you noticed that certain fish are swimming together. Was that it? Different groups of fish are swimming together. I would absolutely believe. And there are different species of fish in here as well. Both are excellent observations that I absolutely agree with. Maybe a couple of your scientists in the room also noticed those observations too. Do we have any more? Camila, you noticed a lot of different kinds of coral in here. I absolutely agree. We see not just one kind of coral, but we see so many different kinds of corals in here. If you were to touch them, try to think about what they would feel like if you were to touch these different kinds of corals. There are so many different species of coral, which is amazing. Excellent observation, scientists. Let's keep those rolling in if you got them, alrighty? we're going to take a closer look on coral. Well, before I move on, do we have any more observations? Actually, we have some of our AOP volunteers watching. Hello, my friends. Thank you for watching. That is awesome. Any more observations before we move on? If not, that is A-OK. Excellent. A-OK for this AOA. Am I right, folks? Alrighty. Let's zoom in on coral a little bit more. We're going to talk a little bit about what coral is. In your class or maybe with your friends that are around you, think about, what do you think coral is? I've heard people say it looks kind of like a plant. I've heard people say it kind of looks like some kind of algae. Maybe you think it looks like an animal of some sort. I want you with your groups, or if you're just by yourself, you can make some notes, maybe a little pros and cons list. Do we think coral is a plant or an animal? If you think coral is a plant, I want you to move your body like this for a plant. If you think that coral is an animal, I want you to make, what do I want to do for an animal? I want you to go like this for an animal, almost like you have animal paws, okay? So this for animal, this for plant. What do you think? Give you a couple seconds to decide, and then I'm going to go ahead and give you the answer. And we got some more observations. While you make your decision, I'll get in some more observations. Ooh, excellent. So we have some answers in the chat as well, which is wonderful. Angelina said that there are so many different colors of the fish or the coral. I'm sorry. Of the fish? Of the coral. Why are there so many different colors of fish? Excellent question, Angelina. I will answer that question by asking you a question. Do you look like any of your other friends that are around you right now? Any other scientists? Do you look exactly the same? No, you all look a little bit different, right? Same for our fish. There are certain species of fish that might have some similar characteristics like shape and some different kinds of colors, but there are so many different species of fish. Fish and other kinds of animals really like to use the color of their body to their advantage. What else do you notice about this habitat too? Would you say it's kind of dark and dreary, or would you say that there are a lot of colors in here? If you said a lot of colors, I would absolutely agree. So all of these fish are going to be really bright and colorful, or have so many different colors on them so they can blend in with their habitat that is really beautifully colored. Excellent question, Angelina. And one of our scientists had an answer for our plant versus animal debate. One of our scientists said that they think coral is an animal. And you would absolutely be correct, my friends. Even though these look like beautiful plant structures, or maybe some kind of foliage that you would see in someone's backyard, or succulents. I know here in California we got a lot of succulents, right? These are actual living animals. Isn't that quite incredible? They are a part of a very special family of animals called cnidarians. Now, I'm going to jump over to my document camera really quick, and I'm going to write that word out for you so we can spell it together, okay? Cnidarians is a big word. I do have some examples of coral here that I'm just going to move on out of the way. I will show you these in a second, I promise. So, cnidarians starts with the letter C. Believe it or not. Kind of interesting, right? Cnidarian. And new word of the day, cnidarian. Cnidarians are animals that can sting. So I'm going to write stinging animals. Oop, almost didn't fit it, but I did. Cnidarians are animals that can sting or have stinging cells on their bodies. They use their stinging cells for a couple of different things. Two that I can think of are to catch their food and to protect themselves. There are a couple of different kinds of cnidarians that call the ocean home. I'm wondering, my friend Cole behind the camera, can you surprise me with another kind of cnidarian? What do we think? What is related to our coral? Have we seen a creature like this before? Yes, no, maybe so. This, my friends, is an anemone or a sea anemone. We see a lot of these here in Southern California, especially in our tide pool areas. Now, our anemone, all around their body over here, are their stinging cells. In the middle of their body is their mouth. So they're going to use these tentacles, these stinging tentacles, to grab a hold of their food and pull their food into their mouth so that they can't eat. This is also a wonderful form of protection for this animal too. Cole, do we have another animal that can use stinging cells in both of those ways that I just mentioned? Excellent. What is this, my friends? Ooh. This is a beautiful jelly. This particular one is a moon jelly, which we do have here at the aquarium in one of our touch pools. Moon jellies are quite special. Even though they still can sting, those stinging cells are super teeny tiny. So, if we humans were to touch the top of this creature, or the bell, we would be very, very safe. We won't feel any sting from the moon jellies because we have a lot of layers of skin on our hands, on our bodies. They only eat teeny tiny pieces of plankton. So we are way too big for these specific jellies to sting us. However, there are some other jellies that have really long stinging cells, like our sea nettles. Those ones would definitely be able to hurt us humans. So, just to be safe, whenever you're in the ocean, you come across a creature like this or our anemones, it's always safe just to keep your distance, respect their space, and respect their home. Let's not touch anything out in nature. Let's only touch things when we're in the safety of an aquarium, and you have a wonderful educator like myself and the rest of my coworkers and volunteers tell you when to touch and how to touch. Perfect. So these are two wonderful examples of other kinds of cnidarians. Now, let's get a closer look at that coral, because there are some different components that make up coral. Coral is an animal, but I want you to think of it kind of like an apartment complex. I live in an apartment, and in my apartment, I have a couple other people that live around me in one big building. So think of coral itself as the apartment, and then inside the coral, there are tiny little houses or tiny little homes and spaces for something else to grow in there as well. Coral itself is a wonderful invertebrate creature, which means that it doesn't necessarily have bones, but it does have a structure. It does something to give itself structure. And what it does is that when these animals are tiny little polyps, what they do is they kind of secrete a sort of calcium carbonate around them, which makes it seem like it's a skeleton, right? So I'm going to actually jump back to my document camera, and I'm going to show you some examples of what that calcium carbonate looks like. Here are some different forms. Ooh. Are we good? Yes, we are. Perfect. Of coral. Oh, we have another observation. What is up, my friends? Oh, I love that. Our decorator crabs have a really cool relationship with anemones as well. They're able to, sorry, can you say that last part one more time? Oh, they can camouflage themselves as cnidarians. I really like that. Absolutely. So decorator crabs are known for putting all kinds of fun stuff on their backs to be able to blend in or camouflage with their environment. I love that you know that fact, my friend. That is super cool. Keep sharing those observations or keep sharing those fun facts that you guys have. I love to hear them. Alrighty, my friends. So here are some up close images, I guess, or examples of what I'm talking about here with this whole apartment complex thing. So here's one piece of branching coral. This is a real, we call these biofacts, which means that these are artifacts from animals that were at one point living. Now, do you see? I'm going to zoom in and I'm going to focus it a little bit more. Come on. Come on, focus. You can do it. There we go. Do you see all those little holes inside of our coral? Inside of these little caves, these little openings, is a very special kind of algae. This algae and the coral are best friends with each other. They really cannot survive without one another. Now, the best friend that I'm talking about, they have a very long, cool name. Are you ready to see the name? My friend Cole's going to pop it up on the screen for me. Their name is zooxanthellae. Zooxanthellae is a really cool kind of algae that lives inside of these little crevices, these little openings. Now, the zooxanthellae, it's able to do a lot for the coral. It can do things like provide oxygen for the coral, provide food for the coral, and even clean it out if it gets a little bit dirty. Now, the coral actually gives zooxanthellae a really cool gift too. Coral is able to protect zooxanthellae because it's so teeny, teeny tiny. It gives them an awesome apartment building to live in, and it also gives them some really important supplies and chemicals that they need in order to do something called photosynthesis. Have we heard of photosynthesis before? Maybe. Photosynthesis is an incredible process that a lot of plants go through when they get their energy from the sun. It turns the cells in their body a really cool green color. It's pretty unique. This can also help our corals change different colors too. I know we have a bunch of different corals that are all kinds of different shapes and colors. Like this one over here kind of looks like our brain coral. Why do you think a coral like this would get the name brain coral? What do you think? Does it look like anything that you're familiar with? Anything that you've seen before? What do you got in your noggin? A beautiful brain. That is absolutely correct. A beautiful brain that's capable of doing some awesome science right here, my friends. Wonderful work. So in all of these little crevices, that is where our zooxanthellae will live. I'll kind of flip it over so you can see the bottom side too. So this is kind of where a lot of those coral polyps will secrete that calcium carbonate. They start growing when they're teeny, teeny, tiny. Now, I'm wondering, here's another one too. Might as well show this one. I'm wondering, Cole, can we get a close-up picture of a coral polyp? Can we see what that looks like when they're teeny, tiny babies? Start thinking. Excellent. This is a really good one. I'm wondering, too, if we could switch over to another really cool, tinier picture, too. While Cole is finding that one, make some observations of these, too. While they look really enlarged on the screen behind me, they are smaller than my pinky. They are super teeny tiny. When these corals start to spawn, this is perfect. Thank you so much. What they do as a giant coral reef, a giant coral that's hard to say. Coral colony. I almost said Connolly. Shout out Connolly, one of my coworkers. As a colony, what they will do is start to spread their gametes at the same time. So all of the eggs will go into the water column. They'll kind of meet up together, form a polyp, and that polyp will start drifting around. And in the first 15 hours, so not even a full day of that polyp's life, they already go through so many different forms and changes before they finally settle down on a rock to form this structure. When they start off, they are super teeny tiny. They're almost microscopic. And you can kind of see where they would start secreting that calcium carbonate. It would be right out from these little branching tentacles over here. That is excellent, my friends. Now, coral reefs themselves, they are one of, if not the most biodiverse areas in or on our planet. Essentially, what that means is that there are so many different kinds of animals that call coral reefs home that it's so important to keep our homes and our oceans nice and healthy. Let's go back to that video that we started with in making our observations. We saw a lot of beautiful different colored fish. We saw some beautiful corals in there. Excellent. That is wonderful. So this kind of looks like, I'm from the East Coast as a quick diversion. And I would go to the city. I'd go to New York all the time, especially in the wintertime as a kid. And when you walk around the streets of New York, it's kind of hectic, right? People are bumping into you, coming at you in different directions, left and right, all over the place. I want you to think of a coral reef like New York, or maybe like any other major city that's closest to you. There is so much life. There is so much movement going on in this habitat. It's remarkable. We rely heavily, heavily on our coral reef specifically because they can protect us. Now, I know you must be wondering, Tina, how on earth can a coral reef protect me if I'm standing here in Southern California or some other amazing state in the country and the coral reef is thousands of miles away? How are they able to protect me? Excellent question, my friends. There is a certain movie where a lovely young woman wants to go explore the ocean, but Dad says no. Dad says no because she can't go beyond a certain part of the reef. Dad says no because beyond the reef, waves can get really, really big. And if there is a storm, all of those waves can come crashing into the coral reefs, but they don't crash on land. When our waves roll over the coral reef kind of stops the waves from getting to land. So any major storm surges, tsunamis, or tidal surges, anything like that, kind of get lowered, or the chances get lowered of that happening on land because of our coral reefs. They provide a wonderful barrier for us and really, really big ocean waves, which is remarkable. Now, we have a comment. Excellent. What's up? Nora, I told you, you are absolutely correct, my friend. Nora said that coral kind of reminds Nora of a skyscraper in New York City. I would absolutely agree. Those things are really tall, right? And all of the fish are kind of like the people. That's exactly what I want you guys to think of, and how it's so important for us as humans to see that life in the ocean is also just as crazy and busy as us humans are. So it's so important for us to take care of them as well as take care of ourselves, right? So we can all coexist and all live together. I love that you made that connection, Nora. Thank you so much, my friend. Excellent. Now, my friends, I would love to talk a little bit more about the relationship that coral has with their friend zooxanthellae. Now, zooxanthellae and coral, sometimes they're a little bit sensitive. I know, I am too. Sometimes I let things affect me that I probably shouldn't. Same with coral. Coral is really sensitive when it comes time for temperature change. Now, if I was an animal, I'd say that I would love to live in the warm water. Coral is exactly the same. Coral loves to be in warmer water. There are certain kinds of softer corals that will live in a colder water environment, like some soft corals live here in Southern California, but most of the coral that exists on our planet is going to live right around, do I have my globe in here? I don't, but that's okay. They live right around the middle of our Earth. I want you to imagine an invisible line going around our planet. Even better, I'll do you one better. Let's go back over to my document camera. Let me draw it for you. I think that'll be even cooler. Oh, let me zoom out. That'll be helpful. There we go. So, if I were to draw our planet, let me move all my awesome coral pieces. I'm going to draw a big circle. Big squeaky circle. Alrighty, I'm going to cut that circle in half. Perfect. This is our northern hemisphere. This is our southern hemisphere. But this line is called the equator. Hope I spelled that right. Pretty sure I did. The equator is what separates our world into two halves. All of our beautiful coral, or most of our beautiful coral, I'm going to do 3 markers at once. I'm going crazy. Are going to live right around the midsection of our planet because they like it really nice and warm. Unfortunately, my friends, the water doesn't stay warm all the time. Sometimes it can get even warmer. Sometimes it can get a little bit colder. But unfortunately, what's happening right now on our planet and in our oceans, temperatures are heating up a little bit. Our climate is changing, and sometimes it can negatively affect animals that live within certain habitats. Now, as our oceans are warming, our corals can actually get sick, and so can that zooxanthellae. If the water gets too warm, the zooxanthellae that lives in the apartment building of our coral is going to want to move out. When that zooxanthellae moves out, all that's left of the coral is that structure that I showed you before, just what looks like the skeleton of coral. This is an event that we call coral bleaching. It almost looks like a coral reef that was just drained of its color. Imagine if you had a beautiful picture book. You just colored your coloring pages, and then someone came along and erased all of the color from your coloring pages. All you would have left is just kind of outlines of what you used to have, right? That's what's happening in our coral reefs right now. And I want you to think of when you get sick. Us humans, our natural body temperature is around 98 degrees or so, maybe a little bit over 98 degrees. If our temperature rises 2 degrees, if we're at 100 degrees for a temperature, that's sick, right? That means that you should stay home from school. Even if you get to 100, 101, gosh forbid 102 fever, that means that you're really sick. and that's only a 2 to 4 degree change. Our corals react the same way to the oceans when they change even just a degree or two of temperature. There are a lot of things that we can do to make sure that our oceans don't warm. Different things like cleaning up after ourselves, cleaning up our planet, going to the beach and just cleaning up either after yourselves or just finding any trash along the beach and picking it up. Make sure we don't cause any or add any more pollution to our planet, to our oceans. We can do other things like carpooling together, saving our energy as well. Saving our water too is also really important to help keep our corals nice and safe. Corals are not only important for us humans, they're also really important for a couple of different animals as well. There's one animal in particular that has some really funky teeth and some really cool colors that is a big fan of coral. I'm wondering if Cole can read my brain. Absolutely. This is a beautiful parrotfish. The parrotfish are known for having some funky little faces, funky little mouths, I should say. Why do you think they're called perfect? Why do you think they're called a parrotfish? Take a look at this mouth and make some observations. Why do you think this animal is called a parrotfish? Does their mouth look like any other animal that might be familiar to you? Absolutely. If you said it kind of looks like a bird beak, I would absolutely agree. They are known for having such strong jaws that they can actually crunch through coral. They love to eat the parts of coral that might not be the most healthy. And they do that because they want to make sure that there are healthy coral reefs around the area. Without them, we'd have pretty unhealthy reefs, which overall is not the best for these critters or for us humans. I'm going to jump over to my document camera really quick because there's something cool I want to show you. I happen to have with me a pretty cool experiment that one of my coworkers did. So a parrotfish that we used to have here at the aquarium was able to give us a little gift. And this gift isn't just a block of what looks like cement. This is actually an imprint of his bite. Do you see these little ridges over here? This is what the parrotfish jaws can do to something, I don't know, ASMR if you guys can hear it or not, of something really hard like a coral. It feels very similar to a texture like the corals. They can chomp right through it. Now, once they eat those corals, what they excrete is actually white sand. I know, crazy, right? So if you've ever been to a beautiful white sand tropical beach, congratulations, you've walked all over parrotfish poop. Isn't that quite exciting? Isn't science incredible, my friends? Amazing. I'm going to go ahead and zoom out. We have talked about so very much today. Just to do a little quick recap, we learned that corals are in fact animals. They are cnidarians, animals that have stinging cells on them, or stinging animals. I should have said animals that can sting, but it's okay. I know you guys get my point. We also learned about their cousins like the sea jelly. We also learned about the, I don't know if I can draw on an enemy, honestly. And look at that. Oh, we got a comment. We got another comment. Go ahead, my friends. Ooh. Ooh, I love that. Someone had mentioned that the parrotfish has one of the strongest beaks. I would absolutely agree with that. They are pretty darn strong, my friends. Very similar to a parrot, right? The parrot that has the largest or the most forceful bite strength, I believe, is the hyacinth macaw. Those ones have incredibly huge beaks with a bite force almost similar to a wolf, if not maybe more. Pretty interesting. Animals and science is incredible. So not only, jumping back to this, did we talk about their cousins and that they're related to the jellies and the anemones, we also talked about where we can find corals too, right? We talked about the equator. So we maybe have learned a couple of new words today. The equator that splits our world in two pieces, where it's the warmest. That's where our corals are going to want to live the most. We learned that corals love the warm water, and they love living with their best friend, zooxanthellae, the little algae that helps give them oxygen and food. It helps them get clean as well. And we learned that zooxanthellae and coral can be a little bit sensitive to our temperature changes, which is why it's so important for us to take care of our earth and our environment to help keep these animals nice and safe. My friends, we did so much today. Thank you so much for all of your participation. If you still have questions and comments, please feel free to continue texting the number, or you can feel free to email us at live@lbaop.org. We'll still get back to those as well. And as well, if you would like to let me know how many kiddos that we had watching my beautiful second grade class, that would be super helpful for us just to gather some more information on how many folks we had watching today. Thank you so very much, everybody, for your participation. I hope you continue to be curious about our environment and about our world. Have a beautiful rest of your day, and we'll see you for our next program that starts in about a half hour at 3 o'clock, all about baby animals. Have a great day, everybody. Be kind to each other. Be kind to your environment. Bye.